After having run a baseline simulation for the wheel center of a Formula SAE race car, we'll optimize and lightweight the part by doing a parametric study in Autodesk Inventor. To modify the wheel center, 3 user parameters are created. These will allow us to change the geometry of the part automatically and easily analyze multiple design options. The first 2 parameters, large red and small red, are already created and applied to the appropriate sketch dimensions. Making their values smaller makes the radial arms of the wheel center longer by removing material near the axle. The third parameter is created to control the depth of the radial arms, and the initial value is set to 30 millimeters. The part was created with a revolved sketch, and the depth parameter is applied to the appropriate dimension in that sketch. Note the fx prefix indicating that the dimension is a function. To analyze different design options based on these parameters, re-enter the stress analysis environment and create a copy of the baseline simulation. This reuses the values such as constraints and loads that we've already defined. Because we now want to assess multiple designs with different parameter values, the design objective is set to parametric dimension. To access the parameters, right-click the part and click Show Parameters. Select the 3 user parameters we've defined. Display the parametric table. Note the 3 parameter names and the default values are listed. A number of input types are available to create a range of values. In this study, a minimum and maximum value is entered. By default, 3 values are created. If required, this can be modified to provide a greater number of values. Based on the range of values, Inventor can generate the geometry for these design configurations. We'll choose to generate all 27 configurations. When you drag the value sliders, the model is updated in the graphics window. For the next stage of the simulation, the maximum values are reselected. To easily compare results against your engineering requirements, design constraints are selected as part of the parametric study. The first constraint is von Mises stress. In addition, a constraint type, limit, and safety factor are entered. For this simulation, the upper limit is set as the yield strength, 276 MPa. This number is divided by the safety factor to determine if the results are compliant. If you select a safety factor of 2, the maximum stress would be 138 MPa. Design constraints for displacement and mass are also created. For displacement, the upper limit is set to 1.25 millimeters. For mass, we'll choose to view the value. A simulation is run using a smart set of configurations. This solves the base configuration and only changes each parameter with respect to the base, and then interpolates the other results. In this simulation, 7 configurations will be run. The value slider is dragged to the left for each parameter to view the results. The minimum values for each parameter are all within the design criteria. Note that the color display does not update for all configurations. Those results were not calculated individually, they were interpolated. To better view all of the results, you can run another simulation using an exhaustive set of configurations. In this simulation, 27 configurations will be run. This will take a few minutes to complete. Notice that the results update slightly because Inventor is now calculating instead of interpolating them. Note that the mass of the part is now 0.656 kilograms, a reduction of 43%. With the simulation complete, results can be reviewed and shared. For example, XY plots of individual parameters can be created. Once you determine that a configuration satisfies your design needs, you're able to promote that configuration back to the CAD model as a CAD edit.